Hello my dear VLSI aspirants. Welcome to Deep Silicon VLSI YouTube channel. Let's have another design challenge. Yes, this is the question. For V1 is equals to 1 sin 3000t plus 36 degrees volts and V2 1 sin 3000t volts. Calculate V0. Assume the logic output voltages of the XOR gate are 0 volts and 5 volts. Guys, here the design contains two comparators, one XOR gate and one low pass filter. They are asking what is V0. We want to find out V0. Let's say comparator. How it works? What is this? How it works? It's a comparator and it works whenever non-inverting terminal voltage is greater than inverting terminal voltage. In such case, it produces logic 1. Okay. Similarly, whenever the non-inverting terminal voltage is less than inverting terminal voltage, then it will produce logic 0. This is very important, guys. If you want to handle the comparators in digital designs, then you need to know this. This is how a comparator works. Okay. Similarly, the second point, that is XOR gate. You know very well, the XOR gate output is always 1 when inputs are different. When inputs are same, output is logic 0. That I don't want to write, you know very well. Similarly, the third one, low pass filter. Guys, here coming to the low pass filter, like if you ask me the function of low pass filter, it determines the average value of the input signal. Low pass filter means integrator, then you can tell easily the low pass filter output is simply the average of its input signal. Whatever you get the output of the XOR gate, let's consider V XOR. Whatever you get the graphical representation, we will, like this low pass filter will calculate the average value of this signal. Right? Now let's have graphical representation, guys, because if we explain the content with respect to the graphs, then it is even more easy to understand the question in the best way. From the given question, there are two comparators. These comparators outputs are VO1, VO2, and these comparator outputs are connected to the XOR gate and whose output is VXOR. And of course, we want to determine the output voltage VO. Okay, let's start. First, we want to do VO2, VO1 graphical representations. Here in the given question, V2 is 1 sin 3000t volts. So here you can see V2. It's 1 volt peak amplitude and 3000t. There is no phase shift at all, 0 degrees phase shift. Okay. Now here this V2 is given to this lower comparator whose another terminal is at ground. So as per the comparator operation, here whenever V2 is positive, then non-inverting terminal voltage is higher. Therefore, in that case, we will get max voltage during positive half cycle. Okay. Similarly, during negative half cycle, this part, the non-inverting terminal has lesser voltage than inverting terminal. Therefore, the output is 0. In the similar way, guys, as per the connections, if V2 is positive half cycle, output is 5 volts, and if V2 is negative half cycle, VO2 is 0. Okay. Now let me draw. Yes, this is VO2. This one completed. Now guys, we are taking VO1. For VO1 the input is V1, which is 1 sin 3000t plus 36 degrees. So here there is a phase shift. let's see here, this is 1 volt peak amplitude and the same like a 3000 T but 36 degrees. So you know very well, let's say this is pi and this is 2 pi. Hence here you can say this will be pi by 2. Here I am taking this as 36 degrees. So everybody, this is very crucial. Hope you remember this particular half box in this graph sheet represents 36 degrees. 36 degrees phase shift. Okay. Now let's enter into the question again. See, this is V1 and inverting terminal has 0 volts, so that here as per the V1, whenever the V1 is positive half cycle, then we get output as maximum voltage 5 volts, and whenever V1 is like less than 0, then obviously V1 will be 0. Let's have here you can see exactly till here the input is positive half cycle, so that output will be max value 5 volts, because in the question they clearly mentioned the input output voltages of an XOR gate is like maximum voltage is 5 volts, minimum is 0 volts. Fine. Now here exactly here guys, till here you can see it's a negative component, therefore it's 0 volts. So let's say quickly, this is VO1. Okay guys, so first part has been completed, VO1, VO2. Now we want to draw VXOR, the output voltage of an XOR gate. We need to know how the waveform looks like. Okay, now you know very well, XOR gate, whenever the inputs are different, output will be logic 1. When inputs are same, output is logic 0. Now you can see here clearly VO2, VO1 inputs this way. At this particular region, the VO2, VO1 values are different, whereas till here it is 1, 1, but here it is 1 and it is 0. Similarly, here you can take this, even here as well, even you can take here as well. Okay, now let's have for a particular period 2 pi. See, this is the period. Okay, now here guys, at a particular this region, as the inputs are different, the XOR gate output will be logic 1, means say 5 volts. Okay, and again here it is 0 only, because the input is here, VO1 is 0, VO2 is as well 0. Similarly guys, the same like this. Now here guys, it is a periodic signal, because see, this is a total like the given period, means you can say here this one, this is the period, this, and in this here this is pi, this is 2 pi, you can see here pi, right? So we want to find out this point and this point from the graphical representation, like especially at V1, this half box is 36 degrees I told, then obviously what will be the value here? It is pi minus 36 degrees. This will be 2 pi minus 36 degrees. So the same, this component will be repeated in a given period 2 pi. So the same like this. Okay guys. Welcome back. Now guys, we understood how we got this output waveform. This is the output waveform of a XOR gate, VXOR, this one. They are not asking you draw the output waveform of XOR gate. They are asking us what is the value of V0. I have told you already here the low pass filter determines the average value of its input signal. Then the signal is here. Then what is the average value? Area by period. The total period, if you see the graph, it's a 2 pi. Then the V0 is equals to 1 by 2 pi. And area calculations, we use integration. That is from pi to pi minus 36 degrees to pi. It is 5 volts, 5 dt plus again from 2 pi minus 36 degrees to 2 pi. 2 pi minus 36 degrees to 2 pi. It is again 5 dt. Okay. Now guys, here you can take the 5 common. It is 5 by 2 pi. So that here if you apply integration, it is simply pi minus of minus plus 36 degrees. Similarly, this one 2 pi minus 2 pi plus 36 degrees, isn't it? Yes, pi minus pi gets cancelled, 2 pi minus 2 pi gets cancelled. It is 5 by 2 pi into 36 plus 36, 72. Then guys, here if you take 5 into 72, 360. 2 by 2 pi, 360. 360 gets cancelled. It's 1 volt. That's it. So guys, for this given design, the output is 1 volt. Sometimes they can ask you what draw the output waveform of this like at point P. Like that also they can ask. At the same time, there are more chances. They expect you to calculate the average value and they won't reveal the average value. They tell you the output of the low pass filter. It is simply average of its input signal. So coming to this question, the answer is 1 volt. Okay guys, thanks for watching. See you in the next video. This is Shivaram signing off. Jai Hind.